Good morning, class. This is Tapas Patra. Welcome to another video of Tapas classes. In our previous classes, we have discussed the MCQs of chapter polynomial. Now, in this class, we are going to discuss some more important questions that may carry 2 or 3 marks in your exam. So, let's start today's class. So, the first question is here. Find all the zeros of a polynomial f of x, which is given that x square minus 2x. Now we know that to get the zeros of a polynomial, what are we to do? We have to equate that polynomial to 0. ठीक है ना? Now if we take x common from here, so what do we have? Now sir, x from this option, and x is already taken out, so we have left with minus 2, and that is 0. Now product of two things is 0. That means either the first thing is 0 or the second thing is 0. Yes or no? So from this thing you get the value of x is equal to 0, and from this thing you will get x is equal to 2. So here find all the zeros as it is a quadratic polynomial, so it will have two zeros. So one zero is 0 itself and the second 0 is 2. Okay, so I hope this is clear. Now let's move to the next question. Find the condition that zeros of polynomial this are reciprocal of each other. In our previous class, we have already discussed the concept of reciprocal. So, in case of reciprocal, if one zero is alpha, another zero is 1 by alpha. That means they are reciprocal of each other. And their product, that means alpha into 1 by alpha, will be your 1. Yes or no? The same concept we are going to apply here. So we know that in this polynomial, alpha into beta is equal to your c by a. But in place of beta, we can write alpha and 1 by alpha. And in place of c, that is c, and in place of a, there is a only. Now this will get cancelled and gives you 1. Now if you simplify this equation, you will get a is equal to c. Okay, this a will go to the left hand side and get multiplied with 1, and that will give you a, and that is equal to c. So this is the condition where the zeros are reciprocal of each other. Now let's move to the next question. Find the values of a and b if they are the zeros of the polynomial this. That means the zeros of the polynomials are also a and b, and here the coefficient are also a and b. Okay, so we know that, sir, sum of zeros, that means alpha plus beta, but here alpha and beta are not there. In place of alpha and beta, a and b are given. Okay, so a plus b is equal to minus b by a. That means this is your b, but here the value is given as a, and this, the coefficient of 1 is 1, and the coefficient of x square is 1. So this is your 1. That means we got that, sir, a plus b is equal to minus a. Okay, now if we simplify this thing, you will get that b is equal to, a will come to the right hand side and become minus a, and already minus a was there. So it will become your b is equal to minus 2a. So this is the first condition. Now, if you go to the second condition, that is a into b is equal to c by a. But here c is your b. In place of c, b is there, and in place of a, already 1 is there. So a into b is equal to b. Now, if you keep a here and move this b to the right hand side, it will get divided, and the answer is 1. That means the value of a is your 1. Now, if you put the value of a here, what you will get, b is equal to minus 2 into, in place of a, you can write 1, and that gives you b is equal to minus 2. So here the value of a is 1 and the value of b is minus 2. So I hope this is clear. Now question number 44, we have already discussed this question, so no need to discuss it again. Okay, you may go through the previous videos so that you can get the answer. Now question number 45. Find the zeros of the quadratic polynomial thus much. Okay, so we have already discussed that if we need to find out the zeros of a quadratic polynomial, then we use the concept of factorization. But the problem is that here the terms are irrational. That means they contain some numbers which are in under root. So let's try to solve this thing. So in this question, if you write down the polynomial, so this is your root 3x square minus 8x plus 4 root 3. Now here a is your root 3, b is your minus 8 and c is your 4 root 3. Okay. Now in order to break this thing or in order to split the middle term, we need to check or we need to have two numbers such that p and q such that the sum is your middle term, that is b. Okay, and the product of these two terms should be equal to a into c, that means this term. So this will give you 4 and root 3 into root 3 will give you 3, that means pq will be equal to 12. Now we need to find two numbers such that their sum is minus 8 and their product is 12. As you can see that product of two numbers is positive, that means both the numbers should be negative or both the numbers should be positive. Either if we take 6 and 2, then the product is 12, or if I take 1 and 12, then also it is 12, and if we take 3 into 4, then also it's 12. So we have three options for this value or for this condition. Product of two numbers is 12. That means this number is 6 into 2, 12, or 1 into 12, 12, or 3 into 4, 12. Now, the second thing is that you may take minus 6 and minus 2. That will also give you 12. You may take minus 1 and minus 12. That will also give you 12. Or you may take minus 3 and minus 4. And that will also give you 12. So this is also the possibility. Now you have 6 options left, out of which you have to check for which option this condition also satisfies. Now this condition is p plus q is minus 8. Now if you look 6 and 2, if you take p is equal to 6 and q is equal to 2, then 6 plus 2 that will give you 8, but we need minus 8. If you look at this option carefully, now we have two numbers, one is minus 6 and another is minus 2. So that if we add minus 6 and minus 2, we get minus 8. And if I multiply minus 6 and minus 2, that gives me 12. So the two numbers are minus 6 and minus 2. Now let's try to split the middle term like this. So in place of 8x or minus 8x, I write it minus 6x and minus 2x plus 4 root 3. I hope this part is clear. The main thing is that you need to find the two values or two numbers such that the sum is this middle term and the product of these two terms should be equal to a into c. Okay, now you need to take common from these two things and from these two things. From this, you can see that root 3 is common in both cases and x is also common in both cases. So if I take root 3x from this term, I have left with another x. And if I take root 3x from this thing, so you can see that 6 is nothing but 2 into 3. And again, this 3 is nothing but root 3 into root 3. So if I take 1 root 3 as common, then I have left with 2 root 3. So here minus is there and x and root 3 has taken out. So we have left with 2 root 3. Okay, and similarly if you look at here, so what you can take, sir, minus 2 you may take as common. So if you take minus 2 as common, so I have left with x from here, and from here this is your positive sign, but we have taken negative as common, so we will left with another negative sign. Out of 4 I take 2 as common, so I have left with another 2, so that 2 into 2 is your 4 and root 3 is there. Now, if you look carefully, we have two terms, this one and this one. And this term has x minus 2 root 3 and this also contains x minus 2 root 3. That means x minus 2 root 3 is common in both cases. So, if we take this as common, so we will left with root 3x from this term and minus 2 from this term. Okay. Now we need to find the zeros. That means this polynomial must be is equal to 0. Now product of two number is 0. That means either x minus 2 root 3 is equal to 0 or root 3x minus 2 is equal to 0. Now if this is 0, so the value of x will be 2 root 3. And now if this is 0, the value of x will be equal to 2 by root 3. Minus 2 will go to the right side and gives you plus 2. And this root 3 is multiplied here. So it will go to the right side and will be divided. So the value of x or the zeros of the polynomials are one is 2 root 3 and another is 2 by root 3 or 2 upon root 3. Okay, I hope this is clear. So let's move to the next question, that is the question number 46. In this question, it is being asked us find a quadratic polynomial whose sum of the zeros is 6 and product of the zeros is 9. So we have already discussed that if we want to find a quadratic polynomial, then the formula or then the structure of the quadratic polynomial is like this: x square minus alpha plus beta x and plus alpha into beta. So in place of alpha plus beta, 6 is given to us. So we have to put 6 and here we have to put 9. Now this will give us x square minus 6x plus 9. So this is the polynomial. Now in the second part, it is asking us find the zeros. So to get the zeros, we have to factorize this thing. Now the factorization may occur in two ways. First thing is this may be, you can see that this is your 2 into x into 3 and this is your 3 square. That means this is a square, this is minus 2ab and this is plus b square. That means clearly you can see that this is the formula of a minus b whole square. So here this is x minus 3 whole square. Or you may do like this, x square, and by splitting the middle term minus 6x into two numbers minus 3x and minus 3x, you will get minus 3 and minus 3, that is your plus 9, okay, which is already there. So the two numbers will be minus 3 and minus 3. So taking x common from the first two terms, you will have x minus 3. Taking minus 3 from common from the last two terms, you will again have x minus 3. Now from this x minus 3, from this x minus 3, if we take x minus 3 as common, so we will left with x and we will left with minus 3. So again the same thing is there, x minus 3 into x minus 3. And to get the zeros, equate this polynomial to 0. Now this x minus 3 will be equal to 0, hence you will get x is equal to 3. Again from this thing, x minus 3 is 0, so x will be 3. So here we get two equal roots. So the two equal roots are 3 comma 3. Okay, now you can check also, if you add these two things you will get 6 and if you multiply these two things you will get 9. So this is the question number 46. So now let's move to the question number 47. So form a quadratic polynomial. We need to form a quadratic polynomial p of x with 3 and minus 2 by 5 are the sum and product of its 0 respectively. Again like this question. So I don't think I need to do the question entirely. Just I am writing the answer. This will be your x square minus 3x and minus 2 by 5. So this should be the answer. But if you want to simplify this thing, then do one thing. As it contains a denominator 5, so multiply the entire polynomial with 5. So what we will have now 5 into x square minus 5 into 3 will give you 15x, and while you multiplying 5 with this term, this denominator 5 and that numerator 5 will get cancelled and that will give you 2. So the new polynomial or the simplified polynomial will be like this: p of x is equal to 5x square minus 15x minus 2. Okay. Now move to the question number 48. If alpha and beta are the zeros of the polynomial this one, find the values of alpha plus beta and beta plus alpha. So the polynomial is given us, that is 5x square minus 7x plus 1. Now a is 5, b is minus 7, c is 1. So if I want to find alpha plus beta, this will be your minus of b by a. That will give you 7 by 5. Similarly, if I want to find alpha into beta, this is your c by a. That is 1 by 5. Now, In the question, it is asking us what is the value of alpha plus beta plus alpha. Now to solve this question, you can see that there are two fractions and you need to add the two fractions. So taking the LCM of the two fractions, you will get alpha into beta in the denominator, and alpha will get multiplied with this alpha, and that will be alpha square, and this beta will get multiplied with beta, and that will give you beta square, and in between them there is a sign of positive. Now this alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta, and that is divided by alpha beta. Okay, so in place of all the things, let's put the values. Alpha plus beta is your 7 by 5, so whole square, minus 2 into alpha beta is your 1 by 5, and again 1 by 5. Now if you simplify this thing, that will give you 49 by 25, and this gives you 2 by 5, and this is your 1 by 5. Now let's equate all the denominators. Let's make the denominator 25. This will be 49 by 25 minus, if I multiply 5 on the numerator and denominator, so it will be your 10 by 25, and this will be your 5 by 25. Okay, now if you solve the numerator only, so you will get 49 minus 10, that is 39 by 25, and here you will get 5 by 25. Now if you simplify this, this will give you 39 by 25 and multiplied by the reciprocal, that is 25 by 5. Now here 25 will get cancelled, and the answer is 39 by 5. Okay, so I hope this is clear. Now let's move to the question number 49. Again, in this question, alpha and beta are the zeros of the polynomial. This is given to you, and the polynomial is x square minus 4 root 3x plus 3. Okay, so this is the polynomial. Then find the value of alpha plus beta minus alpha beta. Okay, so alpha plus beta will be your minus b by a, and here minus is this, and b is your minus 4 root 3, so this is b, and by a is your 1, so this is your 1, so this will give you 4 root 3, and again alpha into beta will be your c by a, so c is 3 and a is 1, this will give you 3. Now the question is asking us alpha plus beta minus alpha beta. So in place of alpha plus beta, put 4 root 3 as we just found it. Then in place of alpha beta, put 3. So this will be the answer. Okay. Let's move to the question number 50. If one of zeros of the quadratic polynomial is negative of other, find the value of k. Already we have discussed this concept in our previous class, that if one zero is alpha and another is the negative of the first one, that is minus alpha, then what will happen, sir? Now alpha plus minus alpha will get cancelled, and this kind of polynomials will have no linear terms. If you remember it, I have already told you that where the two numbers or two zeros are negative of each other, in this case there will be no linear term. That means this term where you can find x, this is your linear term, this should not be there. That means the value of its coefficient is 0. Okay, now as you can see, k square will be equal to 0 by minus 42, that will give you 0, and k will be equal to 0. Now the value of k is 0. So in this question, the value of k will be equal to 0. Okay. If one zero of the polynomial this is 1 by 2, find the value of lambda and the other 0. Okay. Now again this is a type of question which we have already discussed. Still then let's try to do it again. 1 0 is given 1 by 2. That means in place of x you have to put this value. So what will happen, sir? Now 2 into x square can be written as 1 by 2 whole square plus 3 into, in place of x, 1 by 2 plus lambda. Okay, and that should be equal to 0. Okay, now 2 into, this will be 1 by 4 plus 3 into 1 by 2 plus lambda is equal to 0. Now 2 and 4 will get cancelled. This will give you 1 by 2. Okay, this will give you 3 by 2 and plus lambda is equal to 0. Now this will gives you 4 by 2, which ultimately get cancelled and gives you 2 plus lambda is equal to 0. So lambda is equal to your minus 2. So in this question, lambda is your minus 2. But the question is not over yet. Now we need to find the other 0. Now if we put lambda is equal to minus 2, then what will be the polynomial becomes? Now the polynomial now will look like this, 3x, and in place of lambda we put minus 2. Now what you have to do? Factorize these two things. Now what we have to do? Factorize this polynomial so as to get the zeros. So if we factorize this thing, you can clearly see that we have to take two numbers such that sum will be 3 and and the product will be 2 into minus 2, that is minus 4. So let's check what are the numbers which can give us minus 4 as the product. So you may see that 4 into 1 may give you 4, but we need sir minus 4. Hence either 4 will be your minus 4 and plus 1, that will give you minus 4, or 4 into minus 1, that will give you minus 4. Okay, now you can see that in this case if we add these two terms we will get minus 3, but here 4 minus 1 will give you plus 3. So the answer or the two numbers are 4 and minus 4. So if I write it here, 2x square plus 4x minus x minus 2. Okay. Now if you take common from here, that is 2x can be taken out. Now 2x can be taken out common. So we will left with x here. And out of 4x, if we take 2x common, so we are left with plus 2. And here as you can see, minus is common in both the cases. If I take minus 1 as common, I have left with x plus 2. Now both the terms contains x plus 2, so x plus 2 taking as common, we will left with 2x minus 1. Now to get the zeros, we have to equate this polynomial with 0. That means x plus 2 is 0. So from this thing we can get x is equal to minus 2. And if 2x minus 1 is 0, so we will get x is equal to 1 by 2. Already this value is given to us, so we need to check the second value. So we are left with the second value, that is the value of x is also minus 2. So the other 0 is minus 2 and the value of lambda is also minus 2. Okay. So now let's move to the next question, that is question number 52. Find the value of k such that the polynomial this has sum of its 0 equals to the half of their product. Okay, try to solve the question. Now in this question, you can clearly see that a is your 1, b is your minus of k plus 6, and c is your this much portion, 2 into 2k plus 1. Okay. Now if I want to find alpha plus beta, then what will happen, sir? Minus b by a. So minus of b is your again minus k plus 6. Okay. So this will give you minus and minus, that is your k plus 6. Clear enough? Similarly, if you want to find alpha into beta, this will give c by a, and the c is 2 into 2k plus 1. By opening the bracket, you will have 4k plus 2. This 2 into 2k, 4k. This 2 into 1 will give you 2. Okay. Now, according to the question, it is given us that the sum of its 0, sum of 0 means alpha plus beta, is equals to, that means is equals to half of their product, half of their product, that is alpha into beta. So in place of alpha plus beta, put the value k plus 6 and half is there, and here you will have 4k plus 2, or you may write this like this, half into 2 into 2k plus 1. Okay, this one. Okay. So from this thing you will get k plus 6, and from this thing 2 and 2 will get cancelled, you will have 2k plus 1. Okay, now simplify this thing. Let's move k to the right hand side, that will give you 2k minus k, and let's move this 1 to the left hand side, that will give you 6 minus 1. So 6 minus 1 will be 5, and 2k minus k will be k. The value of k is your 5. Okay, the value of k is your 5. I hope this is clear. Now let's move to the question number 53. If the zeros of the polynomial this are double in value to the zeros of this, find the values of p and q. Okay. Now let's try to understand what is given to us. There is a polynomial 2x square minus 5x minus 3. Now it have two zeros. Let us assume one is alpha and another is beta. Now we have another polynomial x square plus px plus q which have also two zeros. And now the two zeros of this polynomial are double of the zeros of this one. That means we have two zeros alpha and beta. So here the two zeros will be 2 alpha and 2 beta. Okay. So the question is given that the zeros of this polynomial, the question is given that the zeros of this polynomial will be double of the zeros of this polynomial. Okay. So let's try to find out the zeros of this polynomial. Then let's double it and then find the values of p and q. So we have the polynomial 2x square minus 5x minus 3. Now let's try to factorize this thing. Now how to do the factorization? Now take two numbers such that their sum will be minus 5 and product will be minus 6. Okay. Now product is minus 6. That means you may get 6 into 1, that will be minus 6, or you may get 6 into minus 1, that will also give you minus 6. So if you see that this will give you, when you add these two numbers, that is minus 6 and plus 1, that will give you minus 5. So the numbers are very much easy. That is your 6x and plus 1x, or you may write simply x. So taking 2 and x as common, so we will have x, and from this thing minus 3, and there is no common term, so we will take 1 as common, so we will left with x minus 3. Now x minus 3 is present in both the terms, so x minus 3 taking as common, we are left with 2x plus 1. Now to get the polynomials, or to get the zero of the polynomial, let's equate with 0. So now this x minus 3 is 0, or this 2x plus 1 is 0. I have already discussed this thing. We have already discussed this thing several times. So don't waste much time. So let's just solve this question. So the value of x is 3 and minus 1 by 2. So if I assume this is your alpha, this is your beta. Now these are the zeros of this given polynomial. But we have another polynomial. So we have the new polynomial as x square plus px plus q. Now if we want to write the polynomial in form or in terms of its zeros, so we can write it like this: x square minus sum of zeros, but here the zeros are 2 alpha and 2 beta, so we can write it 2 alpha plus 2 beta into x plus product of zeros, that is 2 alpha into 2 beta. Okay na? Now okay, so what will happen, sir? X square minus bracket alpha is 3, so 2 alpha will give you 6. Again here beta is minus 1 by 2, so 2 beta will give you minus 1, and x plus, again 2 alpha is 6 and 2 beta is your minus 1. Okay, now x square minus 6 minus 1 will give you 5x, and 6 into minus 1 will give you minus 6. Okay, so this is the polynomial, but actual polynomial is given like this. So you can clearly see that x square is equal to this x square. Here plus p, the coefficient of x is equal to the coefficient of x here. That means p is equal to minus 5. And from this thing you can see that q is equal to minus 6. So the answers are here. P is your minus 5. So the answers are here. P is your minus 5 and q is your minus 6. So I hope this much question is enough for today. So let's wind up the class, and thank you class for being attentive.